All right. Hello, ladies and gentlemen. Oh, I am dealing with some hiccups at the moment, so pardon any annoying interruptions on this video. Now, you are going to need a couple of things in order to follow along on this problem. The first is your good, old, trusty friend, Worksheet 2.5, the worksheet I told you we would be coming back to over and over again. Good news, though, it's linked in the same place where you got this video. So the link you followed to get here from Canvas should have also been a link that will take you to this with the key. These are actually already balanced, so you don't have to worry about that part. The second thing you're going to need is periodic table. Now, you do need the front, but more importantly, you're probably going to want this, which is a much cleaner version of this that I have scribbled down up here. So that will help quite a bit as well. My computer is telling me to update, and I am not going to do that right now. So bear with me one moment. Remind me tomorrow. Okay. So we are going to be doing question 26 from worksheet 4.3. Question 26. In reaction F, how much hydrogen gas is needed to completely react with 27.94 grams of iron 3 oxide? That is what we have to determine. This is an actual stoichiometry problem. Normally, you would not have the in reaction F. Eventually, you're just going to get the question starting here, and you're going to have to, you'll be given the two reactants, and you'll have to figure out what the products are. And I may or may not give you one of those. So for this one, though, I have written reaction F up here, or typed reaction F out up here, but you can also find it on this worksheet if you want to pull it up there. All of the equations that are the reactions that are referenced in this are going to be off of worksheet 2.5. So, first thing we have to do is identify our known and our unknown. The known is always the thing that we are actually given in the question. And as I told a few of you, it's the number that you're given. So number right here, that's our known. So 27.94 grams of iron 3 oxide. That is our known. Now what I want you to do is to actually make a list here, known equals, and write it down. And you want all three components, the number, the units, and the formula. So 27.93, that's a 4, not a 3, 27.94 grams of iron 3 oxide, which is going to be Fe2O3. Hopefully, by now, you should know how to get that formula. So our known is this right here. That is our known. And it says at the beginning of the question, how much hydrogen gas is needed to completely react with this mass of iron 3 oxide? So our unknown is this, the H2, hydrogen gas. Now, one thing that is not terribly clear from the way this question is phrased, it says how much. Unless you are given a unit, if you see how much, you assume you are looking for mass. It is not always going to say what mass or how many grams. Frequently, it's just going to say how much. Well, we measure how much most often with mass. So how much is referring to the mass that we're after. So we are looking for the mass of hydrogen gas. So our unknown is going to be mass of H2. So how much mass of H2? Now down here, our actual table, we are going to start the same way we always do by writing our known. 27.94 grams of Fe2O3. Now, before we do anything else, and you should always get to this point first, but before you do anything else, you need to go to this thing here, and you need to go, okay, what is my unknown? Where is my unknown? We know that we're after the mass of H2. Okay, now this is broken up into the top half and the bottom half. The bottom is all known. The top is all unknown. So our known is the mass of Fe2O3, or the mass of our known. That's what we're given, is the mass of our known. And what we're asked to find is the mass of our unknown. So we are going from this point on this tree, or this table, graph, what is it? Web, that's the word I'm looking for. We're going from the bottom web here to the top of the web here. We are crossing I'm trying to do my finger thing backwards here. From 3 of these purple arrows, 3 of these, that means this is a 3-step problem. So we're going to have 3 fractions that we have to use to get from here to here. So we have to put these blue things into the table here in the order that we cross them, going from our known to our unknown. So the first thing is the molar mass of the known. Well, the known is Fe2O3, so we need the molar mass of Fe2O3. I am going to pause this, calculate it, put it on the board as the fraction, since you should all already know how to do that part, and we will move forward from there. All right. So here is our calculation to get the molar mass of Fe2O3. Gives us a 159.69. So we plug that into our fraction, which gives us this as our fraction that must go into the table. So, as always, we use our units. We have grams Fe2O3 in the numerator over here. So that means this needs to have grams of Fe2O3 in the denominator. So this is going in upside down. 159.69 G. No. Yeah, 69G. Fe2O3 per 1 mole of Fe2O3. Our grams of Fe2O3 cancel. And with that, we have made it to moles of Fe2O3, or moles of known. We have crossed this arrow and gone from here to here. We are now in moles of known. So now we need to get from moles of known to moles of unknown. And this is the part that is new, because we have not done molar ratio before. So for molar ratio, we need to go to our balanced reaction. And my tip is to always follow this format when you first write it down: known over unknown. You see that? You can see that. Not well, but I'm running out of colors. So we need to put coefficient moles of the known. So coefficient for the known is 1 mole of the known, Fe2O3, over the unknown. So coefficient 3 units moles of the unknown, which is H2. That is, wow, that is kind of hard to see. that is going to be our molar ratio for this problem. Now, once again, we put it in so that our units cancel. But this time, both of these are moles. So we have to look not just at the units, but also at the formula. And this is why I've been telling you since we first started this, you have to write the formula as you're going through this. It is important, not just to make figuring out your final answer easier, but because here, if you don't have the formula, you can't figure this out. So on the top, we have 1 mole of Fe2O3. On the bottom, we have 3 moles with H2. We need moles of Fe2O3 to cancel. That means moles of Fe2O3 needs to be in the denominator in our second fraction. So this needs flipped. So I'm going to put, see if I can do this a little easier to read. 3, hang on. 1 mole of Fe2O3 to 3 moles of H2. Moles of Fe2O3 cancel, and now we are in moles of H2. And now we have units of moles of unknown, because H2 is the unknown. That is the thing we are trying to find, is H2. So we have made it from moles of known to moles of unknown. And that just leaves the final step, the molar mass of our unknown, in order to actually calculate the mass of our unknown. So once more, I'm going to pause that, do that calculation, and then I'll replay it so that you guys can see it and check. But I would encourage you to do this without watching because some of you need to practice. Okay, so we have 2 hydrogen atoms. So that's going to be 2 times 1.00795. 2 times 1.00795 gives us, out of the calculator, 2.0159, but that is a 5-digit number when this was a 6, so I added a 0 to the end to bring us back up to 6 digits, which is where we want to be if we can. Plug that into our equation, and now we are at the final step. We are in moles of H2 here, so we need moles of H2 in the denominator. So this time, we're going to leave it as is. We do not have to flip it this time. 90 grams H2 over 1 mole of H2. And the moles of H2 will cancel, leaving us at long last in units of grams of H2, which is what we want. We want the mass of H2. So if we solve this table now, it will give us our answer in these units, mass or grams of H2, or hydrogen gas. So let's solve this thing. To solve it, we multiply just like we have been, 27.94 times 1 times 3 times 2.0159. That will give us our numerator, and then across the bottom, 1 times 159.69 times 1 makes the denominator actually really easy. So I'm going to do that one now. And I'm going to use a calculator to do the rest. 27.94 times 3 times 2.0159 equals 168.972738, and that's going to be grams of H2. We then need to divide these two numbers, which I should actually probably do before I do this. But before I do that, I'm getting ahead of myself, we have to do something to this top number, and that is called sig figs. So currently, we have way too many digits in this. So we have 4 digits in this number, 6 digits in this number, so this needs rounded at 4, which is Really annoying. Okay, so we need to round this up to 9. So we drop the rest of this. That 7 is going to make that 9 go up to a 10. And the 10 is going to move the 1 over here. So this is going to become 169.0. Let me know if that didn't make sense. But because the 7 is making the 9 become a 10, we have to turn the 9 into a 10, which is going to carry the 1 over to the 8, which is why we end up with this. So now we take this number divided by this number, 169.0 divided by 159.69 equals 1.058300457. Sig figs 4 and 5 becomes 4. So we just drop the rest of this since the 3 does not change anything. Oh, I usually write that down here. That's right. Okay, so this number I should have written here. So I'll go ahead and do that. 1.058300457. And then we round it to 8, drop the rest of that, and so we get 1.058 grams of H2 as our final answer. That was a little beefy, a little longer than what we've done before, because you need 2 molar masses in order to do this, and you have to calculate both of them. But this is the process for solving a 3-step problem. Now, I want to point out, there are a lot of different 3-step paths on this. This is the most common one. And what I'm going to do is I'm going to stop it here. This is where I'm going to stop because there's already a 20-minute video. This is the one I'm going through in class on Wednesday. I'm recording this Tuesday night. I'm going to go through this in class on Wednesday, and then Thursday and Friday will be work days. So the worksheet 4.3 will have this one and one more, question 27 presumably, already worked out for you so that you can go ahead and you'll have 2 examples to work on or look at there. So that is where I'm going to end this. I hope this helped at least a little bit. Remember, you can go back and rewatch parts where you got a little confused or ask. I'm going to end this, as I've said about 3 or 4 times now, here at 18 minutes. So have a wonderful day, and I will see y'all next time.